Okay, in this example, we put together a hypothetical scenario where we have a 20 Fahrenheit suction temperature and an 86 Fahrenheit condensing temperature. And the purpose of this hypothetical example is to compare and contrast ammonia, R717, to R22, to give an idea of how one might go about selecting one refrigerant over another. And we'll look at a variety of different characteristics ranging from pressures to thermodynamics, safety, and regulatory concerns. So we're going to look at all these different selection factors, and I'll provide commentary on how one might think about these. So let's start with operating pressures. At a 20 suction temperature, the corresponding saturation pressure for ammonia is 33.5 psig, whereas for R22 it's 43.1. Those are very similar to each other and not enough really to give an advantage of one to the other. I suppose a higher pressure on the evaporator is advantageous, so maybe a slight edge to R22, but really not enough to make a decision based off of. Similarly, looking at condensing pressure, based on an 86 Fahrenheit temperature does not result in any significant difference. We're within 5 psi of each other at 154.6 for ammonia and 158.2 psig for R22. So looking just at pressures, these two refrigerants are very similar. Now looking at thermodynamics, the refrigeration effect. This is now where we'll start to see a deviation. And what is the refrigeration effect? You might remember that's the amount of BTUs that each pound of refrigerant can absorb inside the evaporator. And ammonia really dominates in this case over R22, 478.5 compared to 71.3. So I'm gonna give a plus to ammonia here and a minus to R22 because this means we're gonna need much less pounds of ammonia compared to R22 for the equivalent system doing the same function. However, refrigeration effect only tells part of the story, as you can see in the next row, which is labeled compressor displacement, having the unit CFM per ton of refrigeration. So this is how many CFM, cubic feet per minute, do the compressors need to move in order to provide a ton of refrigeration. So you can multiply these numbers by whatever your system tonnage to get the total displacement, but this gives us a comparison. And now you can see these values are very similar to each other, with the R22 system being slightly higher, 2.62 compared to 2.47 for ammonia. Lower numbers better, right? The less amount of CFM we have to provide would be better. But comparing to the refrigeration effect, these are nearly the same, which points to the fact that the specific volume of ammonia is very, very large compared to R22. In other words, ammonia takes up a lot more space. Ammonia vapor takes up a lot more space than R22. And this really affects equipment selection because the more CFM that are required, or the more cubic feet the gas occupies, the larger the compressors will need to be, the larger the pipes, larger the vessels, you get the idea. So we're really slight advantage to ammonia, but not even enough really to give it a plus. These two refrigerants are very comparable when looking at compressor displacement. Moving on to theoretical discharge temperature. This is the temperature that we would expect to see at the outlet of the compressor at these conditions, assuming isentropic compression and no compressor oil cooling or any form of cooling on the compressor. And ammonia is nearly 180 Fahrenheit, whereas R22 is 118. This is a big advantage to R22 compared to ammonia, because heat causes us all kinds of problems, wear and tear on the machine, friction. It's gonna cause us to have to invest in oil cooling systems and compressor cooling systems in order to bring this temperature down. So advantage certainly goes to R22 here. Now looking at some of the safety factors of these refrigerants. First, flammability and toxicity. ASHRAE 34 categorizes refrigerants according to their toxicity and their flammability. Ammonia is considered a B2L refrigerant. B indicating that it is toxic, 2L indicating that it is somewhat flammable. The flammability range is from 1 to 3, 3 being the highest flammable, 1 being the lowest. 2L is on the lower half of the category 2. So ammonia is toxic and is somewhat flammable, whereas R22 is an A1, non-toxic and non-flammable. that's a big advantage to R22. In this case, I'll give it another plus. We'd like all the things being equal, we'd love our refrigerants to be safe to work around, okay? Vapor density, which is the ratio of the weight of the refrigerant vapor compared to air, is displayed in this bottom row on this side of the table. And we would prefer that the vapor density be less than 1, because that means that the vapor of the refrigerant is lighter than air, or in other words, that the vapor will tend to rise when it leaks, as opposed to in the instance of R22, it is 3 times heavier than air, which means a leak will settle on the ground and displace the oxygen that humans need to breathe. So it's an advantage to ammonia to have a vapor density less than 1, disadvantage to R22 and other halocarbons to have such a high vapor density. Moving on to exposure limits. The PEL is the permissible exposure limit, and that is what OSHA has defined as the concentration that a worker can be exposed to without respiratory protection for an 8-hour day. For ammonia, federally, that's 50 parts per million. Here in California, where I'm recording this video, OSHA says it's 25 parts per million, but we use 50 for this case. For R22, it's 1,000 parts per million. So all other things being equal, it's an advantage to R22, because that means you won't have to implement a respiratory protection program, or if you do, it'll be at a much higher concentration compared to ammonia. However, it's not on the table here, but I would like to point out ammonia has a very self-alerting characteristic, very pungent odor, easily recognizable, which is an advantage to ammonia compared to R22, which is difficult to identify a leak just using human senses. All right. As it relates to first aid, if you were to review the safety data sheet, or SDS, for either one of these refrigerants, they would have very similar first aid measures, which would say if you get the refrigerant on your skin, get to water, an eye wash, a safety shower, and irrigate with copious amounts of water. However, it's more critical in the case of ammonia because the ammonia will actually be attacking the skin tissues. Both refrigerants could be very cold and cause frostbite or even freeze clothing to skin. So in that regard, first aid considerations are very similar. Either way, irregardless of which refrigerant you choose, you'll need to have access to an eye wash and safety shower where work will be performed. So pretty similar there. I'll put my plus and my minus for the PEL, so I'll add those. Cost and availability. So this is an interesting one. Both of these refrigerants historically have been widely available and used all throughout the United States and the world. Meaning there was a lot of vendors familiar with working on them. It was easy to purchase, relatively easy to install. It wasn't kind of like a niche industry. In fact, if anything, R22 maybe was more widely available just because the commercial refrigeration industry tended to use it because of the safety concerns. So maybe it would be as though the R22 had 2 pluses, but ammonia was still available and cost effective, maybe 1 plus. However, since 2010, when R22 production and import was banned in the United States, it's become much more costly and a lot less available. These 2 pluses are kind of gone. It's really turned to a minus in this comparison. All right, next one is compatibility and reactivity. Neither chemical or neither refrigerant is considered reactive per se. However, the ammonia is incompatible with certain materials that would be commonly used in other types of refrigeration systems that use halocarbons, namely copper and brass. Copper is an excellent heat transfer metal used in a lot of heat exchangers and piping, but because of its incompatibility with ammonia, copper and its alloys like brass can't be used. That's a negative for ammonia, whereas the halocarbons have more choices available to them in material selection. Okay, now we'll look at some environmental and regulatory concerns. Concerning the environment, ammonia has to get a huge plus just to fill our whole box there, because ammonia is a natural refrigerant. It has no global warming potential and no ozone depletion potential. So from an environmental standpoint, it is very attractive. Whereas R22 has an unacceptably high GWP and an ODP greater than 0, which is really a huge negative for it. Enough negative that I'm gonna go ahead and put about five minus signs here in my hypothetical example, because it's really this that led to R22 getting banned in production, being banned in the US, which has led to the increase in costs and availability of it, and it's a very big downside for R22. Finally, regulation. No matter which refrigerant you choose, you're gonna be faced with a regulatory context that you need to be aware of. For ammonia, that usually kind of starts with the Risk Management Program, RMP, and Process Safety Management, PSM. These are involved programs that require teams of folks with expertise in order to implement them effectively and maintain compliance. So this is certainly not a positive from the standpoint it's going to cost money, it's going to take personnel and resources to implement. But there is no really more positive outcome if you went the R22 or halocarbon route, because there's a whole barrage of their own regulations. I just listed a couple here. EPA 608 certification for technicians that handle synthetic refrigerants, the AIM Act, which is currently being implemented by the EPA. And here in California, we have the Air Resources Board with their regulations on synthetic refrigerants. So I got to give this one a minus as well, because either way you go, you're going to be dealing with regulations. So I hope that's helpful, just to kind of go through a hypothetical, and depending on any given situation, maybe one of these rows could have more impact than another to a specific owner or to a specific application. But this helps understand how one might go about deciding between two different refrigerants.